begin. First off, go to the website and click on the button for example number 1. Let me know when you're ready. Okay, looks like we've got the majority of you. The first thing that you need to know about Demi numbers is that they are based on just 4 symbols which represent the numbers for 1, 2, 3, and 4. These 4 numbers are rotated counterclockwise and compounded to make higher numbers. There are 4 extra symbols for special numbers. Below the main table, there's an illustration that shows an easy way to remember the base numbers. It's a coincidence, but the Demi number 1 looks like the vertical line of the Arabic numeral 1. The Demi number 2 resembles the curve of the Arabic 2. Demi 3 resembles the connection between the upper and lower arcs of the Arabic 3. And the number 4 resembles the angle in the lower right corner of the Arabic number 4. So if you ever get confused, that's one way to try and remember them. Once you've memorized the numbers 1, 2, 3, and 4, the rest of the numbers use them as building blocks. The number for 5 is a numeral 1 which has been rotated 90 degrees counterclockwise and should be read as 1 times 5. The numeral for 6 is the number 5 with a number 1 added to it. 7 is the number 5 with a 2 added to it. 8 is the number 5 with a 3 added to it. And 9 is the number 5 with a 4 added to it. To get 10, the number 2 is then rotated 90 degrees counterclockwise, representing 2 times 5. 15 is a rotated number 3, and 20 is a rotated number 4. There are only 4 numbers that do not follow that system. They are 0, 25, Cyclic Zero, and infinity. Infinity is actually a number unique to Demi because it is written as a numeral rather than a mathematical symbol. The symbol for 0 is a dot. 25 can be written in 2 different ways, as an X when it's being shown as a single digit, or 10 when it's part of a numerical progression. The symbol for infinity is an X over a cross, and the symbol for cyclic zero is a diagonal line. Cyclic zero is a special number that is used when a numeric sequence is repetitive and takes the place of both 0 and the highest number. It's most often seen on Demi timepieces, where it represents both 25 and 0 as you go around the dial. The reason why 25 can be written as 10 is because the Demi use base 25 mathematics rather than base 10. In base 10, the places from right to left represent 1s, 10s, 100s, 1000s, etc. In base 25, from right to left, the places are 1s, 25s, 625s, 15,000s, 625s, and so on. As with Arabic-based math, the Demi wrote their numbers from right to left, with the far right place before the decimal point representing single digits, the next place to the left representing 25s, and so on. Richard Watson mentioned that Demi numbers might have been derived from a system of counting on one's fingers. Instead of counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 across your fingers, instead you have the fingers of your right hand representing the ones place and the fingers of the left hand representing the fives place. So you keep track of how many times you've reached 5 on your right hand by raising a finger on your left hand. And once you've hit 25, all of the fingers on the left hand will be raised while you have none on the right. With a little bit of practice, you can actually do simple calculations using that system. For instance, if you wanted to subtract 4 from 5, you would have one finger on your left hand, which you would then close while raising 5 fingers on your right hand to represent the 5 numbers. Then you just lower the fingers, 4 fingers on your right hand, and guess how many you have left? That's your answer. You can both add and subtract using that system. Are there any questions about what I've covered to this point? If there are no questions, then click on the button at the bottom of the web page to see example number 2 and let me know when you're ready. The next thing that we're going to talk about is the correlation of Demi letters to numbers. The Demi had 35 letters in their alphabet. There were 24 base letters and 11 letters with alternate pronunciations. The letters are made from stems that have tops and bases added to them. An explorer named Christopher Gilson was the first person to notice that there is a connection between Demi numbers and Demi letters. He discovered that the shapes of the glottal stop and the 4 stems used in Demi letters looked very much like the symbols for the numbers 0, 1, 2, 3, and 4 if you removed the boxes from around them. This was later confirmed by Richard Watson, who said that he wondered if anyone would ever notice it. That caused Christopher to re-examine the other numbers, and he noticed that they seemed to have a relationship to Demi letters with the bases and tops. This led in turn to the discovery that the Demi alphabetical order is in fact numerical order. The letters are arranged according to their corresponding number from 0 to 24. The 11 letters with alternate pronunciations are kept slightly separated and are also in numeric order. That means instead of having a separate alphabetical order, Demi letters are arranged in what can be called alphanumeric order. A question that the MIST community had for a long time was whether the Demi letters were derived from the numbers or if the numbers were derived from the letters. The answer is that the letters came first and the numbers were created by simplifying their shapes. Richard said that he'd intended for the numbers to just be the basic shapes. It was Rand Miller who wanted to put them in the boxes, and since he was the boss, that's what they did. The reason why Rand wanted to put them in the boxes, by the way, was to make sure that they were separated from the lettering and there would be no confusion. Any questions about that? Okay, we'll continue now. The chart on this page shows some conversions from base 10 to base 25 and how the numbers appear in Demi. The first 4 numbers are places in Demi mathematics, and the final 3 rows show some of the differences in how base 10 numbers are expressed in base 25. The 5th line is how Ginn wrote the 233rd age in one of his journals. He wrote it in English and mentioned the 9/8 RD age, which made no sense until you realize that he was simply directly transliterating the base 25 figure without converting it to base 10. Because of that, many explorers mistook the name of the place as age 98, which is wrong. It's really his 200th and 33rd age, which explains the RD in the journal entry. By the way, the curly brackets in the 7th line are used because a single place in Deni notation can be from 0 to 24, and that cannot be expressed as a single digit in Arabic notation. The brackets are used to show that the two digits of 15 are both in the 25's place. Without them, the number would appear to be 1,150 instead of 1 in the 625s, 15 in the 25s, and 0 in the 1s. No questions on this? The next chart shows the basic Deni numbers. In Deni, one does not say 6. Instead, the term is 5 and 1, or Vagafa. 12 is 10 and 2, or Negabri. As you can guess, Ga is the Deni word for and. The names of Deni months use a different system of numbers than normal. My own speculation was that they might be from a much older form of the Rone language than the Deni used, the way that month names in English use Latin numbers in some of their names. For example, the Sept in September, the Oct in the October, the Nov in November, and Des in December are 7, 8, 9, and 10 respectively in Latin. However, when I asked Richard about it, he refused to confirm or deny the theory. The second set of number names are only on that chart are only used in the calendar. There are only 10 months in a Deni year, but I was able to extrapolate words for 11 through 14 from those words. For 15 through 19, I guessed the word for 15 based on the observation that A and E are converted to O in the regular words for 1 and 2, and that the suffix for 10 remains the same as the regular version. That means that the adjectives for 15th through 19th are conjectural. Since there is no example of how I would have been converted, I cannot guess the words for 20 through 24. So I colored all of my conjectural numbers blue to separate them from the ones that are confirmed. So in the chart below, the chart you're seeing, the words for numbers used for Deni months are written below the regular words. The Deni names for the various numbers are Run for 0, Fa for 1, Bri for 2, Sin for 3, and Tor for 4. Vat is the number 5, but from that point on, they shortened the word Vat to Va. So 6 is Vagafa, or 5 and 1. And so forth and so on. Then we get down to 10, which is Nevu, and in the following words, that gets shortened to Ne. Similarly, 15 is Hebor, but that gets shortened to He in following words. And then when we get to 20, which is Rish, it gets shortened to Ri for the following words. And then 25 is Fa-Si, which is 1 times 25. Okay, are there any questions about how the Deni names work? By the way, also on that chart over to the right-hand side, you will see the adjective forms of those words. For example, for zero, we have rildo, which means none or nothing. And then for all of the other words, a suffix ets or ets gets added to the words in order to convert them into adjectives. For those who may have just joined us, we're referring to a web page in order to see the examples I'm talking about. Okay, at this point I'll assume that it's okay to continue. And now we are looking at what are the places in Deni numerical notation named. Just as we have words for the places in base 10, such as tens, hundreds, thousands, 10,000s, and so on, the Deni had names for the places in their notation, and they use suffixes to represent them. Currently, we know the words for up to 6 places, and so we can write the names of complex numbers at least up to 244,140,624, which, if I'm getting this right and don't trip over my tongue, should be Rigatorpolo, Rigatormel, Rigatorlan, Rigatora, Rigator si Rigatora. And I lost it at the end there, but close enough. In practice, a suffix is attached to a number indicating its place and value, and then single place numbers are added to bring the sum up to the desired value. As an example, 26 is fa si fa, or 25 plus 1. 628 is fa ra sin, or 625 plus 3. 31,258 is Brilan Vagasin. The highest value that can expressed in any place is 24, so 624 is Rigator si Rigator, or 600 plus 24. The chart that you're seeing on that page was suggested to me by Koravev of the Guild of Messengers. And this is an example of how a complex number using Deni notation would be laid out. And I'll give you a moment to take a look at that. Below that example is an explanation of the known place value suffixes. So we remember me mentioning that Fasi, the Deni name for 25, is actually 1 times 25. Brisi would be 2 times 25, or 50, and Sinsi would be 75, or 3 times 25. And of course it goes up from there for the other known suffixes. I gave this particular lecture one time before, also during an anniversary celebration. And at that time, I had wanted something that was previously unknown to fans to reveal at the lecture, just so that it wouldn't be rehashing things that some of you may have already known. and that was when I discovered that there actually was such a thing as Deni mathematics. Virtually nothing is known about it, however. The DRC never released any documents that contained equations or any that even dealt with the subject at all. All we have is semi-official speculation. Because we had no idea what Deni mathematics symbols look like, I had to fake a few for the purpose of my examples. The math signs that you see are in no way official and are just placeholders until such time as authentic ones are found. I spoke with Richard Watson about the subject briefly, and by his recollection, the Deni might have used a system of notation in which the operands preceded the operators. As an example, take this simple problem, 5 plus 5 equals 10. Richard told me that when they were discussing Deni numbers in the planning stages, they toyed with the idea of Deni mathematics, and Rand was the one who proposed that they use this system, which is a variation on what's called reverse Polish notation. However, it never got any farther than that one discussion because they never needed to show any math equations in any of the games. Supposedly, the Deni would have written the 5 plus 5 equals 10 problem as 5, 5 plus. We don't know yet how they would have displayed the result. Provisionally, I do it by displaying the result followed by an inequality sign. So, in Deni, the problem would be 5, 5 plus, 10 equals. And if you look at the example I gave you, you'll see what it might have looked like using my imaginary math symbols. Let's take a slightly more complex problem. 9 plus 9 times 12 minus 4 equals 144. The supposed Deni system would not use brackets because you apply the operands in the order they appear. The curly brackets in my example are just there to represent the numbers which are 2 digits in Arabic's numerals, but are only 1 digit in Deni. So the problem that wouldn't be written 9, 9 plus 12, 4 minus times 5, 19 equals, and might look like something like the example I show you on that webpage. In that example, 9 and 9 are followed by a sign to add the second 9, then 12 and 4 are followed by a sign to subtract the 4. Then comes a sign to multiply, and that gets applied to the results of the first two operations. And that pretty much concludes the lecture today, so I hope that's helped you and you found it fun and interesting. Are there any questions about anything I've covered during this lecture?